Hello and welcome to day 2 of learning ML with chatgpt. So let's get started. So I've set up the Google Colab here, which is basically just Jupyter Notebook, and let's test it. So yesterday we learned about linear regression, but it didn't really explain the code examples as well. So I'm going to ask for it. So please give me lesson day 2's lesson. I'll just copy day 2. And today, please give me more in-depth explanation for each code sample / snippet and a deeper explanation of each concept. Okay, let's see what we have. Well, so we have data processing. Okay, so data processing is a crucial step in machine learning. In the machine learning pipeline, it involves transforming raw data into a format that is more suitable for model training. Proper preprocessing can significantly improve the performance and accuracy of your models. So we can do data cleaning, which is the process of detecting and correcting or removing errors and inconsistencies in the data to improve data quality. Common steps: handling missing values, filling in missing values, or removing data points from missing values, removing duplicates, ensuring that each data point is unique, outlier detection, identifying and dealing with data points that are significantly different from the rest. Then we have normalization. So this one is just like summarized. We're just basically making the data so it's easier, well, so that the model can be trained, so there's no like outliers and like just ones that aren't fully complete. Normalization: the process of scaling numerical data to a standard range, often 0, 1 or -1. This is important because many machine learning algorithms perform better when input feature of similar scales. Min-max scaling rescales the data so that it falls within a specified range. And z-score standardization scales the data based on the mean and standard deviation, transforming the data to have a mean of 0 and standard deviation of 1. One-hot encoding. Definition: a technique used to convert categorical variables into a binary. Okay, so I have done one-hot encoding. This is necessary for models that require numerical input. Example: if a dataset has a feature color with categories red, green, blue, one-hot encoding will create 3 new columns, red, green, blue, where each row will have a 1 in the corresponding column and 0 in the others. Definition: the process of dividing the dataset into 2 parts, one for training the model and another for testing. This helps evaluate the performance of the model on unseen data. Typical ratio: a common split is 80% of the data for training and 20% for testing, though this can vary depending on the size of the dataset. So this is what we saw yesterday with when we're passing in 0.2 into the function. Code examples: data preprocessing using Panda and scikit-learn. We'll walk through preprocessing a sample dataset covering data cleaning, normalization, one-hot encoding, and splitting data into training and testing datasets. Okay, I'll do copy and paste the code at the end. First, let's import the necessary libraries. So we have pandas, numpy, scikit-learn. So pandas are a powerful library for data manipulation and analysis. Numpy, a library for numerical operations. So train, test, split, a function from scikit-learn to split the dataset. I think this is what we used yesterday. Min-max scaler and standard scaler one-hot encoder, preprocessing tools from scikit-learn. then simple inputter, tool to handle missing values. Okay. So step 2, load and inspect the dataset. Let's create a simple dataset for demonstration purposes. So it looks like of age, salary, and city. And we're gonna convert this to a Python data frame. Pandas data frame. PD9 represents. Okay, so this represents our like missing values. So that's what we're gonna do with the like inputter, or we're gonna remove the values. Data frame, a table-like structure in pandas that holds data in rows and columns. Printdf displays the data set. You should see missing values in the age and salary columns. So step 3, we need to clean the data. So inputter, simple inputter strategy was mean. Okay, so fills missing values with the mean of the column. Okay. Fit transform computes the mean and replaces missing values. So df apply the okay, fit transform, and then after running this, the missing values in. Okay. Normalization. Min-max scaler scales features to a range, typically not on 1. Fit transform learns the scaling parameters, min-max, and scales the data accordingly. The salary column will now be scaled between 0 and 1. Let me see the salary. Okay. Okay. So now, one-hot encoding. So this is when we convert it to like 0 and 1. So encoder, one-hot encoder, sparse equals false. Converts categorical variables into binary columns to 0 or 1. Sparse equals false ensures the result is in a dense array. Encoded cities equals. So let's say we're just doing it for cities here. Python data frame encoder dot fit transform city. Learns the categories and creates binary columns. And then we have pd.concat at the end, combines the original data frame with the new one-hot encoded columns. The city column is replaced by new binary columns: city Chicago, city Los Angeles. Okay. Yeah. So what we're basically doing here is, so in the dataset, what we've got is we've got all these cities, and we're going to split these up to several different columns. So we can do, what does it say here? So we one-hot encode them. So we do city underscore Chicago, and there'll be like a 1 if it is Chicago City and 0 if it's not. Splitting the dataset. So df.drop salary axis x all features except. So why are we dropping salary? Oh, we're trying to. Okay, so y is what we're gonna test. X-ray, then we test. Okay, so the target variable we want to predict randomly splits the data into training and testing, ensures the split is reproducible. Random state. Assignment. Pre-process a dataset and prepare it for training. Okay, so I'm just going to copy all this code for now, and yeah, we'll see. So we've got the header files, and I've got the data. Wait, so this was, yeah, just the data set. This is cleaning the data set. Pardon. And we have normalization, which if we go back up here, we can see normalization is the converting of numerical data to standard range. So we're like eliminating like all the other, like, so I guess what it would be is like 25 is 1, 30 is 2, this is maybe 3, 4, 5, then like that's a standard range. So when it's repeated, like we don't have just like, we can make it smaller, the data in which we've got to store. So where did I get to? I got to after the inputter. Normalization. One hot encoding. And then splitting the data set. Okay, so here we're just going to import all of the necessary libraries. We'll just wait for this to execute. It's a bit slow because there are a lot, 3 seconds. So we'll just run through these individually and see like the changes we get. So we can see we got a few NANs, not a number. So we can see this is a table. Right. So now this inputter was the data cleaning, I think. So what this does, it replaces all the nans and it gets the average of this salary column, and then it just puts them in there. And we'll see that second one from the bottom is the same as the one that goes up 4, 5, 6, yeah. So you can see those are the same because they are the averages. So what we do here is we do data frame at age and salary. So we're passing an array and we're getting them from those columns from the data frame. We're just assigning them to the fit transform, which just gets the mean and fills in any blanks. So here we're scaling the data set to I don't think it's actually, I know there is. So we're doing it in a given range. So this one's 0 to 1, and we can see like first one 0. This is the lowest value, and the highest value. Let's see, is there a high value? Yeah, highest value is 1. Then we just put those all in a range between them, so we can have a specific range. Okay. Now we want to encode them. So I think the data set will be flipped on its side, so that I'll just do this a minute. Flipped on its side, so like city, New York. I think we'll see just 1s and 0s in these columns. Yeah. Okay. So we can see 1s, which represent it is city of Chicago, and yeah, just running through this code. So we do fit transform like we did with the scalar, and we've also apply the encoder to the city column and convert it to a data frame. Assigning new column names for the encoded variables, get feature names out. City encoder. Yeah, so we fit transform, already done that. So now data frame, we're concatenating the encoded cities to this, and I assume we are removing the original city column. Yeah, drop city here. Okay, so now we can see we're training the data set, and the X-train shape is, you can see this is like shares the same first value. So we drop the salary, and then because what we want to predict is salary. So X train, X test, Y train, Y test. and we split it using train test split, then we can do the shape. So this was just the assignment, which is basically the same as what we've just done. So this concludes your day 2 lesson on data preprocessing. This is a foundational step in machine learning, and mastering these techniques will help you build better models. Feel free to ask any any further questions if you need any clarification. So I'm just going to review this lesson and see what we've learned. Oops, not this one. So we need data cleaning. So I'm trying to so this is the first one. Correcting moving. Did we actually do any data cleaning in this? I think we just did normalization, didn't we? Oh. Let me see. Oh no, so it was data cleaning. Data cleaning, so what we did here is we just got the averages and we put it where the NAN was. So we can use the whole data set and there won't be any like erroneous values. So 2, normalization, so we're converting it to the numerical data to a standard range. So this was where the lowest value is going to be 0, like this one, and the highest value is going to be 1. Then the rest just fit in to that range, 0 to 1. Then we do one hot encoding, and we do that by getting all the cities and converting them into. So we're just making another data frame with encoded cities. We're doing encoder.fit transform. We're making another one. Then encoded cities.columns. We're assigning the names. Then we're concatenating both axes 1, which is like columns, and then we're dropping city. And as you can see here, these cities, we've removed the actual cities column, and we've assigned the columns name to get feature names, and we've made it like that. Okay, so now into the next one. We're just splitting the data set, and into the Y train and the X train. And you can see that the Y train and X train are different shapes. So I'm just going to ask a question. So I have a question regarding the different shapes of the X train and Y train. Please go into more detail on why they are different. Great question. The different shapes of X train and Y train come from the fact that they request different aspects of your data. Let's break this down in more detail. So X. In your case, X contains all the columns in your data frame except for salary, okay? These columns might... Oh, right. Age, yeah. Since X is a 2D array, 2 dimensions. A single column. Ah, right, okay. After splitting data set and your training, you end up with 2 arrays. This contains the training samples of the features. Right, okay. Oh, it's got a nice table, ChatGPT. Okay, yes. This helps a lot. Now, so what I am going to try and do though is I'm going to use the linear regression model that we learned from yesterday's lesson to let's see. So we need to make the linear regression model. Have we already got linear regression? I don't think we do. What was the... So import Let me just copy this first. Okay, and then what we can do now is we can fit the model to these. That's the wrong one. And I'm just going to add the next one in as well. And then we can predict. And then we can just make a nice anyway, instead I'm just going to do this. Add 2 more code snippets, and I'm just going to copy matplotlib. I know, so linear regression is, I don't know why I did that, but linear regression isn't the proper model to use on this, I don't think. Because in the previous dataset, we didn't have as many features. What's wrong with this? Next test. Yeah, so that's the problem. They're different shapes. Okay. I'll just delete this for now. What model could we use to train this data on now? Let's see. Nature. So it is a regression problem. Okay, it's giving me a whole lot. Please provide the additional. Okay, linear regression. Okay, I'm just going to copy this one. Oh, we need to import. What's the name? Metrics. Okay, let's now run this. Oh, our spread score is very bad. Okay, but MSC is worse. Less worse, rather. Is better, as I should say. Yeah, so that will conclude today's lesson. Thank you for watching.